All right, hey everybody. It's Friday. I thought I'd give you a 10-minute video on looking at what's inside your export folder that we export from Spectronaut. So today I have downloaded a awesome data set. This is data set P from Proteome Exchange, PXD013658. And this is surpassing 10,000 identified and quantified proteins in a single run in optimizing LCMS conditions. So you guys can download this and do it yourself. I recommend it. The whole data set, I think, is like 1.1 terabytes or something. But you could download the Spectronaut file. It's like, 8 or 10 gigabytes. So totally reasonable for these day and age. So what we do when we return data to people, we return the S&E file or the Spectronaut file. And we also return a bunch of text and PDFs that come from the Export All feature in Spectronaut. So the way you do that, and you don't have to do this because we'll do it for you, but if you wanted to do it, you go to the analysis view, right-click on the tab, hit Export All, and you could select all the reports you like. And usually I do this. I don't return the MS Stats report because I don't really like MS Stats very much, but you guys are welcome to do it yourself. So, and give MS Stats a whirl. And then once you do that, it'll take a couple minutes and it will export to your directory. It will give you, I put it in this directory called Spectronaut Demo. It'll ask you where you want to put it. But it will have the file with a folder with the file name, which will be here. And let's see what's inside. Okay, so you have a bunch of folders and text files. There'll be something called calibrations. You could safely ignore this. This is how Spectronaut calibrates both the indexed retention time, which I talked about in a previous video, or the MS1 and MS2 mass. I don't know why you would need this, but if you want to really geek out on it, you can. The run summary folders contain summaries of all the runs. This Spectronaut file had 6 runs, so a 3 versus 3 run. Something, I think it's some kind of cancer versus normal. And so each one of these will have, I believe this is TSV, but they label them an Excel file. And you can just click on them and let's see what's inside. Okay, it usually gives you an error because they label it as Excel file, but it's not really an Excel file, so it'll give you this kind of warning. You can just ignore it. All right, so this has all the info of the runs, for example, the precursors, which is important, the modified peptides, protein groups, proteins. These are all kind of explained in previous videos. And these are all pretty useful to look through. You can see proteins, they are identifying 14,000 proteins and 10,000 to 10,000 proteins in this run. This is the total number over the entire experiment, but 10,000 is just for this run. So it'll say 10,000 of something, or 14,000 of 15,000, which means there was 14,264 proteins identified in this run out of 15,000 total for the entire experiment. So really good. They are identifying over 10,000 proteins for one run. That's pretty cool. Maybe someday I'll be able to do that. I don't know. There's also cool statistics like cycle time. You see they have a pretty long cycle time, but I think since this run is like 6 hours long, doesn't really matter. Data points per peak. The raw file name, so this will be where the raw file it came from. The instrument, let's see, even the date that it was acquired, which is cool. All sorts of other useful stuff, like it's an Orbitrap. Even gives you I think the serial number of the instrument that it was run on somewhere. Anyway, that's what those are, and there should be run for every single run in the experiment. There was 6, so this was a 3 versus 3. Okay, the analysis overview. This is actually super useful. These are the results for the entire experiment. So for example, average profiles, sparse profiles, and full profiles. I explained this in a previous video. I don't remember which one that is. I think it's like one of the, I don't know, one of the earlier ones, one of the long ones probably, unfortunately. So that's pretty useful. Gives you a whole experiment-wide overview. The analysis log, not too much useful information here, but if you scroll all the way down to the bottom, there's some little statistics that it tells you. But this might be useful if you see a problem with the run, for example. You'll see a candidates, and because we set conditions in this experiment, it will do statistics for you. And another video coming up, I'm going to explain how they do the t-tests and how to reproduce that in Excel. But for now, this is a TSV file, so we can drag it into Excel. And you will see the candidates. Whoops, I assume you want things to be valid. Here's the comparison you're doing. Condition numerator, condition denominator. So this is cancer over something called NAT, and I'm sure that's explained in the paper. So the protein groups, average protein group denominator, average log 2, ratio, percent changed, all sorts of interesting things. Q value, pretty useful. These things you could bring over to your statistician. And this is kind of an older, I think this was processed with an older version of Spectronaut. So the one you get from us will be a little different. Okay, condition setup. This will tell you what condition was set up and what run was associated with it. And usually we put your sample name in the run so you can check for errors. So this is the condition, something called NAT versus cancer. Replicate, label, color, file name, and run label. Sometimes the run label will be different than the file name, but there's always a way to go back and check if someone screwed something up. Okay, experimental overview. Let's see what this is. I kind of dragged these. Oh, this is a text document, so let's just click it to open it. The first part of this is pretty useful. Like if you're writing a method section, or this is what I refer back to when I write the method section, but you could do it yourself. Usually we do this, but you're welcome to give it a shot. And if you've done it, if it's the first time you're doing it, it might be a good idea to let us see it. This is basically all of the settings that you want to include in your method section in the paper. And those will be all at top. These are the windows they used. And it will say it for every run in case they were different. So anyway, super useful, good for the method section. Here's a heat map. If you had conditions, you can see the heat map. Unfortunately, it's not interactive. So it basically gives you an overview of how well things are clustering. You could see this one here, it looks a little different than the other two. So basically that's what I want to look at. I want to look at if all the conditions are clustering together. They don't have to, but it's really good when they do. Kind of look for outliers because it's not interactive. There's not much you can do here. Memory consumption, I totally ignore that. I'm not even going to open it. You can open it if you want. Normalization, this is how the response of the experiment between the non-normalized and normalized. Basically, if there's big differences between your runs, you'll see it here. You don't want there to be, unless you expect them. And I think I've covered this in a previous video. Protein FDR histogram, this is actually pretty geeky. You can safely ignore it, but it kind of tells you how they're doing the scoring at a 1% and 5% Q value. So these are our decoys. Everything in proteomics these days uses decoys to try to estimate a good result from a bad result. And so you can see the distribution of the bad results and the distribution of the good results. And here's the cutoff we use at 1%. Here's the cutoff at 5%. So you can get a kind of an overview of how much bad data is being put into your result, whether you basically have this result or this result. Basically, we filter them at a 1%. All right. So these are the reports. Let's open them and see. There's a peptide report. These are pretty big. Let's see if I can open them in my little laptop computer. It looks like it's opening. Sort of. Let's see if I broke it. Looks like I might, let's see, have that open already. Cancel. Let's see. I don't, so I don't know what that error was about. But let's try again. So these reports, if they don't say pivot, will be in a long format. We'll say read only. this format. It'll give you that error again. Just hit yes. We'll see. This is a pretty big file, so we'll see if I'm able to open it. What I also like about Spectronaut is it will give you the parameters for every one of the reports, so you can see if the reports were weird somehow. You can look at the parameters of how it was generated. I think it gives you like this data is too large, it won't even load it. Oh, there it is. Okay, I don't know what it was confused about. This is kind of a long format, so each peptide will be, let's see, where is the peptide? That will be elution group precursors. So these are the peptides, the proteins they're associated with, the Q value for their identity, and the quantity of the peptide. If you're looking for an individual peptide, this may be a good report to open. If you're looking for PTMs or a specific peptide for a specific protein, you can easily filter these in Excel and R and show all the peptides for a specific protein. Okay, I'm going to close that because it's way too big. There is the peptide quant pivot. So this will be the wide format. So if you guys are familiar with R, that'll be a long format. This will be a wide format. So it's basically a real simple one, peptide on each line with each column being the quantities across all 6 of the runs in these experiments. So if you're interested in one peptide, you can see how it's changed in the quantities in each experiment. Remember, these are a unitless quantity, number of quantities. So they don't really have any units, but they're you can use them across the rows. Protein quant normal. This will be the same as the peptide quant normal, except the long format of the proteins. I will go ahead and open the protein quant pivot. This is usually what the statisticians like. It'll give you the error again. So on each one, you'll have the accession numbers of your proteins. Usually when I do this, I add the description too and the number of peptides. So your reports will vary depending on what things you're including. And remember, Spectronaut has a very powerful report generator, so you can add all sorts of stuff to your report. But this is just the proteins in the rows and the quantity in the columns. And this is something you can give right to a statistician. All right, and last but not least, the Volcano plot. It's not really interactive, so it's not really useful, but it's nice to view. So, it's usually Volcano plots are log 2 fold change on the bottom, log 10 p-value on the y-axis. So you can kind of see which ones have a large fold change with a low p-value, for example. And that's it. So thanks again. I hope I didn't go too long. We'll see. How long am I? Oh, I don't know. We'll see in a little bit. Anyway, thanks again. That's kind of what we include in the export folder. It's usually better to look at it by hand in the Spectronaut viewer, but if you don't want to do the viewer, you can get most of the information from the export folder, which we usually zip up and send to you. Okay, bye everybody. Thanks.